NASA is very interested in agriculture in general, not because we built any of our satellites for agriculture, but what we do is we are measuring the Earth in every part of the electromagnetic spectrum with 19 satellites in low Earth orbit right now. And what we're doing is we're taking some of those measurements and we're figuring out a measurement called evapotranspiration, which is you take evaporation from, say, a farmer's field, and transpiration, which is the plant breathing and putting water vapor into the atmosphere. And from that evapotranspiration measurement, you can determine how much water is being used, and from that determine a very precise irrigation plan. And so NASA is using its assets to actually help farmers understand their specific evapotranspiration for their specific crops on a specific part of the planet, ultimately so that they can very accurately irrigate. The goal, of course, is to use enough water to make sure your plant has all of the water it needs, but at the same time not so much water that the nitrates in your soil actually erode away. So it's really a balancing act. In fact, in many cases, less water is actually better for your plant than more water. And NASA is helping farmers figure out just exactly how much water is necessary. Now, that's just one of many things we do for agriculture.
Well, clearly in this state, water is critical and always a war.
Yeah.
Is there anything specific or in particular you have been able to deliver to farmers so far?
Yes. So the evapotranspiration numbers, of course, is being done as a partnership between NASA and the University of California Cooperative Extension. So that's being done right now on a small scale. Eventually the goal would be to expand it out to the entire United States. But right here in California, 30% of the water that's used in the state comes from the Sierra Nevada mountains. And it turns out that NASA has some really specific technologies that will help us measure the snowpack in the Sierra Nevada mountains so we can quantify what we call the water equivalent of that snowpack that will materialize in the spring and the summer. So there's two things we want to measure. How much water is in the snowpack, and when will it materialize, along with how fast. When it shows up and how fast is it going to show up. So as you mentioned, state of California, a lot of competition for water. You have agriculture, you have endangered species in the rivers, you have hydropower, which is a necessary part of our power mix here in the United States and especially here in California. We have people that are interested in recreation and conservation, but we also are trying to provide drinking water to the big population centers, Los Angeles, San Francisco. And you take all of this demand for the water, and here's what we know. The demand in all of those sectors is increasing. It's not going down, it's increasing, and at the same time, there is no more water. So what NASA can do is very accurately measure the snowpack in the Sierra Nevada mountains, and then make predictions based on how fast it's melting using another technology that we're very good at called spectroscopy, measuring how much energy is reflecting from the sun off of the snow, taking that reflected sunlight, splitting it into 100 different colors, and then measuring how much of the sun's energy is being absorbed and how much is being reflected. Sometimes it's 10% being absorbed, sometimes it's 70% being absorbed. And ultimately from that calculation we can figure out how fast is the snow melting and when is it going to materialize and where. The goal being to help water planners meet the demand of all these competing interests, and at the same time it's not just meeting the demand, because at the same time we're having to manage floods. So if you're just meeting demand, you're going to want the reservoirs full, but if you're trying to manage floods, you're going to need the reservoirs empty for the eventuality. So what we're trying to do as NASA is provide the science and the technology so that ultimately every drop of water is used for its maximum utility and not a drop is wasted.
When will that estimate, I mean, we're looking at the snowpack right now.
Yes.
When will NASA have its first sort of like, hey, we did it, here's what we think is going to happen in 2021?
So we've been measuring the snowpack now for 5 years, and every year we're getting much, much better at it. And in fact, right now we're really, really good at it using what's called the Airborne Snow Observatory. So we're not doing it from space, we're actually doing it from aircraft using the same sensors that we have on a lot of our satellites. On the aircraft, we can fly low and slow and get very accurate, detailed measurements over the Sierra Nevada mountains. But we're doing it year by year and making sure that the water managers are getting the data that we're providing. I want to be clear because, as you mentioned, this is a very contentious issue. When you think about who's using the water in what amounts, and there's this great competition. NASA is absolutely not involved in making policy decisions. All we're doing is providing data and information for water managers so that they can get the right water, the right places on their time scales. But then also we're bringing it down to a lot smaller of a scale, to the farms themselves, and we're providing all of those measurements from all parts of the electromagnetic spectrum so that farmers can very accurately determine how much they need to water in their little quarter of an acre of their farmland.
So are they able to go on the NASA website and get this information for free?
Not yet. As far as the farmers using our technology to come up with a very accurate evapotranspiration number so they can create their specific irrigation plans, that technology right now is being mastered in a much smaller scale with the cooperative extension of the University of California. But eventually, we want to take that technology, that capability that we're developing, and scale it out, and even commercialize it. Because ultimately, the idea is, the government doesn't want to get in the business of doing things that commercial industry can do for farmers and ranchers itself. But if we can at first prove the technology and then spin it off or license it to commercial satellite operators, then they can ultimately be the ones that make the investments, raise the capital, sell the data to the farmers, and make the money. And all NASA has done is develop the technology.
Shouldn't the data be free?
Well, it depends. In some cases, yes. In other cases, no. Here's the thing. There is always a tussle when it comes to weather specifically. There's a tussle between having a commercial private company provide very accurate weather predictions and whether or not that's a global public good for safety. And so there's this argument: should the government be doing weather or should private companies be doing weather? Well, what we're finding right now is that in some cases private companies can do it better than the government. The question then, is that a global public good for safety? And so this is kind of a tussle. When it comes to a private farmer or a private corporation that's doing farming, trying to get a competitive advantage in the marketplace, they can invest their capital however they like.
No, I guess my argument is if the raw data is coming from the government, that the private company is then packaging and selling.
Absolutely. All of NASA's data is available to the public. Period, end of story. We are a government organization, and we do science and technology, and we provide it all to the public. But again, what we want to do, once we prove the technology, we don't want to invest billions of dollars into an agricultural industry. We're not an agricultural organization. We're a technology and a space organization.
Let me get back to that. You're a technology and a space organization. Why are you focusing on this? And we want to get back to the moon. We want to go to Mars. Why is NASA focusing on this?
So we're not focusing on it. I want to be really clear. What we're doing is we have a whole lot of sensors in space orbiting the Earth. We have a number of missions. We've got, of course, a planetary science division. We have an Earth science division. We have an astrophysics division. We have a heliophysics division to understand the sun. So NASA has all of these divisions. But studying the Earth is part of what we do, and we've been doing it since our inception in 1958. And really all we're doing now is we're taking all of those sensors that we have to understand the atmosphere, to understand the biosphere, the lithosphere, understanding the land, the cryosphere, understanding the polar ice caps, understanding the hydrosphere, the oceans. We take all of these kind of parts of the Earth's system that are all working together in many ways, and we're now saying, wait a second, we can take this capability and we can apply it to a farmer's land and help them increase their crop yields, decrease their water use, and preserve their nutrients. Now, if it's available and we can do it, the question would be, why wouldn't we? So that's what we're doing. This is another way where NASA is actually, supporting industry that we were never designed to support.
Which is happening since the beginning of NASA.
Since the beginning.
Okay, some space questions.
Yes.
Is 2019 the year that American astronauts leave Earth from American soil.
Yes, 2019 we're going to launch American astronauts from American soil on American-made rockets, and we're going to take our astronauts to the International Space Station with two, and this is important, commercial companies. NASA is no longer building, owning, and operating the rockets that are going to take its astronauts to the International Space Station in low Earth orbit. From now on, we're going to be a purchaser of services in a robust commercial marketplace where we are one customer of many customers, and the providers are numerous, competing on cost and innovation to drive down our cost and increase access to space. Now, we're on the precipice of this, and this year, 2019, is going to mark the year where NASA buys the service commercially to get to the International Space Station, and we're buying it right now from two companies, Boeing and SpaceX.
Okay, when and who gets first? Who gets the first trip, Boeing or SpaceX?
Well, it's I'm going to leave it to them, but I will tell you both of them look promising for 2019.
Late 2019, November?
So right now, SpaceX will be launching an uncrewed Dragon crew capsule. So it's a crew capsule, but it will not have humans on board. Right now, the plan is March 2nd, which is less than a month away. And then before the end of 2019, and I'm not going to give you a date, that same vehicle will be carrying NASA astronauts. And then Boeing, sometime maybe this summer, will launch their first vehicle. The thing is this, I think that there's going to be less time between the uncrewed vehicle for Boeing and the crewed vehicle for Boeing, and longer time between SpaceX, which means whoever gets to fly that first crew, we don't know right now. But I will tell you, I'm highly confident that it will be before the end of 2019.
There is, I think, supposed to be an update on the lunar ambitions by the end of this week. Can you give us a preview? And when are we going to get a 2023 still?
Yes.
And the commercial partnership in that?
So, yeah, absolutely. And we're going to make this announcement on Thursday at the NASA headquarters in Washington, D.C., so I don't want to get ahead of myself.
A little bit.
But I'll tell you this. The President's Space Policy Directive 1 has us going back to the moon. This time when we go to the moon, we're not going to leave flags and footprints to not go back for another 50 years. Instead, we're going to go and we're going to stay. So just as I talked about what we're doing with commercial crew, NASA becomes one customer of many customers in a robust commercial marketplace to launch astronauts to low Earth orbit. When I say many customers, there's going to be sovereign nations that have their own astronaut programs, and there's going to be space tourists as well. But we're going to be one customer of many customers in a robust commercial marketplace. Well, what we're going to do now is we're going to take that model. Because of that, costs have come down, access is going up. We're going to take that model and we're going to apply it to everything between the Earth and the moon, so we have a sustainable return to the moon. That's what the President's Space Policy Directive 1 was all about. Go to the moon sustainably. In other words, this time, stay, so we can go back and forth over and over again. And of course, we've got a number of capabilities underway right now, but what you're going to learn about on Thursday is going to be about landers. How do we get humans to land on the surface of the moon? We know how to build rockets. We know how to build spacecraft that can carry humans. We know how to build space stations. But what we've got to do now is we've got to build those landers that can get us to the surface.
And would those be commercial, privately owned as well, contracted out as well?
It's right now it's open. We're reaching out to industry. And we're going to find out what industry is interested in, but I will tell you it's likely to be a public-private partnership. Okay. Here's what we know about the surface of the moon. We now know, in 2009, NASA made a discovery, there's hundreds of billions of tons of water ice on the surface of the moon. What does that mean? That means that you've got air to breathe, oxygen, you've got water to drink, H2O, but you also have rocket fuel on the surface of the moon, hydrogen and oxygen, cracked into its component parts, put into cryogenic form. That's the same rocket fuel that powered the space shuttles, and it's abundant on the surface of the moon. We also believe that there could be a tremendous amount of value in precious metals on the surface of the moon. We hear about rare earth metals. Rare earth metals are not earth metals. Platinum group metal. These are metals that are impacts, asteroid impacts from space from billions of years ago. Well, the thing about the Earth is we have this very active geology and an active hydrosphere. And so what happened a billion years ago is not easily understood today. But on the surface of the moon, where there is not an active hydrosphere, there's not an active atmosphere, there's not an active geology, whatever impacted the moon a billion years ago is right where it was a billion years ago, which means there could be potentially very precious metals in the value of tens of trillions of dollars on the surface of the moon. In fact, Goldman Sachs did a study not too long ago, and they declared that the world's first trillionaire is going to be somebody who does mining on celestial bodies.
Oh, gee, Robert Bigelow, maybe? A couple more questions. Do you think the moon, humans back on the moon by 2023 is your goal?
I think we'll have, the goal would be to have our first human lander on the surface of the moon in 2024.
With humans on it?
Not necessarily with humans on it, but have a demonstration uncrewed. Okay. So this isn't the space race. We're not competing against the Soviet Union anymore. We don't need to do things that would be maybe excessive risk the way we did back in the 1960s. So the first one will be an uncrewed mission.
And humans on Mars in the 30s, you still think? 15
I think that's a reasonable objective. The reason we do all of this at the moon is because it's the greatest proving ground. It's a 3-day journey there and a 3-day journey home.
And easier to get.
yeah, absolutely.
2 more questions. Has the president ever told you he would give you whatever it takes to get humans on Mars by the end of his first term?
He has not told me he would give me whatever it takes. No.
Has he told you can't? Has he asked you if you can get humans on the Mars by 2020?
I will tell you, he's very interested in accelerating the process to get both to the moon and to Mars. He is very interested in that.
And the last question, of all the things you've got going right now, so many, what most excites you?
The idea of finding life on a world that's not our own. Without question, that is the most exciting thing that NASA is doing right now. Just since I've been the NASA administrator for the last 9 months, here's what we've discovered. We now know, because of the Mars Curiosity rover and Mars Opportunity and others, we know a number of things. Number one, we know that there are complex organic compounds on the surface of Mars. That doesn't guarantee that there's life on Mars, but those complex organic compounds do not exist on the moon. They exist on Mars. They're the building blocks of life. It increases the probability that there either is or was life on Mars, but it doesn't guarantee that there is. We now know that the methane cycles on Mars are perfectly commensurate with the seasons of Mars. That doesn't guarantee there's life on Mars. It could be geology, but it increases the probability that there is life on Mars. And the third thing, we now know that 12 kilometers under the surface of Mars, there's liquid water on Mars, 12 kilometers under its surface. What we know about Earth is that anywhere there's water, there's life. And if we can find liquid water on a world that's not our own, the probability of finding life goes way up, and we just found it in big volumes under the surface of Mars. Now here's the important thing. Here's what we know from the discoveries that were long before I was the NASA administrator. We know that Mars used to have a strong magnetosphere that protected it from the radiation from the sun in deep space, just like Earth has. Mars used to have that because it used to have a molten core. And when it had that, you had the magnetosphere protecting it from radiation. The north part of Mars, in fact, 2/3 of the entire northern hemisphere was a liquid ocean on Mars. We now know that. And we know that at one point Mars had a very thick atmosphere. So while Mars, we don't know if it was inhabited or not, we know that it was habitable. And that is an amazing piece of information. If you combine the fact that we know that it was habitable, I'm not saying it was inhabited, but it was habitable, combine that with the fact that we now know that we've got complex organic compounds, we've got liquid water, and we've got methane cycles that are commensurate with the seasons, I'm here to say I think the probability is going up that we could find life on another world, namely Mars. Now I will tell you, we're not going to find bunny rabbits, but what we could find is microbial life, small life on Mars.
Or at least evidence that it once existed.
That would be an amazing discovery, and I think it's important that the United States of America make that discovery.